Qua sono tutte e due magnifiche.
Last night at 7:46 in the evening, the ground beneath Naples shook again. Magnitude 4.7, depth 3 kilometers, epicenter Campi Flegrei, the most dangerous volcanic system in Europe, sitting directly beneath one of the most densely populated cities on the continent. Elevators got stuck across the city. Chunks of plaster fell from ceilings and facades.
Ma i vigili sono stati chiamati, i vigili del fuoco?
Sono tutte e due magnifiche. Sicuro al 100%. Nessuno. Le macchine? No, voglio sapere se c'è qualcuno. No, persone.
Dove stanno?
Stanno fuori, stanno tutte e due bene, stanno tranquilli.
A high-voltage electricity pylon supplying power to Naples collapsed, cutting power to parts of the city before emergency crews restored backup supply.
Le strade sono in queste condizioni, si sono staccati pezzi di intonaco, elementi.
No injuries have been reported, no major structural damage confirmed, but that is not the story here. The story is where this earthquake happened, and what has been building beneath that location for years. Subscribe and turn on notifications, because what is happening at Campi Flegrei is one of the most closely watched geological situations in the world right now, and last night's earthquake is the latest signal in a sequence that scientists are taking very seriously. Let us start with what Campi Flegrei actually is, because most people have heard of Mount Vesuvius, the volcano that buried Pompeii in 79 AD and still towers over the Bay of Naples. But Vesuvius is not the most dangerous volcanic threat in the Naples region. Campi Flegrei is. Campi Flegrei, which translates literally as burning fields, is a supervolcanic caldera approximately 13 kilometers wide. It does not look like a volcano. There is no cone, no dramatic peak, no single obvious crater. Instead, it is a broad depression in the landscape west of Naples, stretching from the city's western suburbs into the sea, encompassing the town of Pozzuoli and dozens of smaller communities. Approximately 500,000 people live directly within the caldera boundary. Another 3 million live in the greater Naples metropolitan area within direct reach of its effects. The last major eruption of Campi Flegrei occurred in 1538, producing a new hill called Monte Nuovo in just 2 days of eruptive activity. But the system has been continuously active in geological terms ever since. And in recent decades, it has been showing signs of increasing unrest that have put scientists and Italian civil authorities on heightened alert. The specific phenomenon driving that unrest is called bradyseism. It is a process unique to active volcanic and geothermal systems in which the ground slowly rises and falls as magma and hydrothermal fluids move beneath the surface. At Campi Flegrei, the ground has been rising, not quickly enough to be visible to the naked eye in real time, but measurably, persistently, and with increasing speed over the past several years. Between the 1950s and the 1980s, Campi Flegrei went through 2 major episodes of rapid ground uplift, called bradyseismic crises, which forced the evacuation of tens of thousands of residents from Pozzuoli. The ground rose by as much as 3.5 meters in some locations during those episodes. Buildings cracked, infrastructure was damaged. The evacuations were expensive, disruptive, and deeply traumatic for the affected communities. Then the ground stabilized. It began to slowly subside, and life gradually returned to something like normal in the communities around the caldera. But beginning around 2005, the ground started rising again, slowly at first, then more consistently, and in recent years more rapidly. Scientists at Italy's National Institute of Geophysics and Volcanology, the INGV, have been tracking this uplift continuously. Their measurements show that the current episode of ground deformation has now exceeded the total uplift recorded during the major Brady seismic crises of the 1970s and 1980s, the ones that forced mass evacuations. In March 2025, a magnitude 4.4 earthquake struck Campi Flegrei, the strongest recorded in the region in 40 years. It sent hundreds of residents into the streets in the middle of the night. Buildings were declared uninhabitable. Schools were closed as a precaution. The mayor of Naples described the situation as one requiring the greatest possible attention. 3 months earlier, a magnitude 6.0 earthquake struck in the Tyrrhenian Sea off the island of Ischia in the Gulf of Naples, part of the same broader volcanic and tectonic system. That event, the strongest to affect the Naples region in years, rattled communities across the area and reinforced the sense among scientists that the entire system was in a period of elevated activity. And now, last night, magnitude 4.7 at Campi Flegrei, 3 kilometers deep. Power pylons collapsed, elevators trapped, plaster falling. The INGV has been careful and precise in its public communications about what these events mean.
Sì, ma è pure pericoloso sta luce di benzina. Ma tu abiti qua?
Sì, un po' più indietro.
E vuoi danno tu?
Sì. Ma infatti stasera sto a fare il turista.
Signora dove? Sì, no, io sono salito, ma ho preso proprio il necessario la montagna per fatica.
Scientists emphasize that ground uplift and increased seismic activity at Campi Flegrei do not necessarily indicate that an eruption is imminent or inevitable. Bradyseism can continue for extended periods without culminating in a volcanic eruption.
Mamma mia! Mamma mia! Mamma mia!
Ma i vigili sono stati chiamati, i vigili del fuoco?
The system can rise, cause earthquakes, unsettle communities, and then stabilize again without producing surface volcanic activity, as it did in the 1970s and 1980s. But scientists also emphasize what they do not know. Predicting volcanic eruptions at systems like Campi Flegrei remains one of the most difficult challenges in volcanology. The underground plumbing of a supervolcanic caldera is extraordinarily complex. Magma, hydrothermal fluids, gases, and pressurized rock all interact in ways that current monitoring systems can track, but not fully predict. The signals that precede an eruption, accelerating ground deformation, changing gas emissions, intensifying seismicity, are also the signals that characterize periods of unrest that do not lead to eruption. The question that Italian civil authorities and the scientific community are grappling with in real time is not whether Campi Flegrei could erupt. It could. Every active volcanic system can. The question is whether the current signals represent a trajectory toward eruption or a continuation of the unrest cycle the system has been exhibiting for decades. Let us be direct about what a major Campi Flegrei eruption would actually mean. Not a small eruption like the one that created Monte Nuovo in 1538. A large eruption, the kind that the geological record shows this system is capable of producing. Approximately 39,000 years ago, Campi Flegrei produced what geologists call the Campanian ignimbrite eruption. It was one of the largest volcanic events in Europe in the past 200,000 years. The eruption sent ash across the entire Mediterranean and into Eastern Europe and Russia. It deposited thick layers of volcanic material across an enormous geographic area. Scientists believe it may have contributed to the decline of Neanderthal populations across Europe by disrupting ecosystems and climate across a vast region. A repeat of that scale is not what scientists are discussing today. The current unrest does not indicate a super eruption is imminent, but even a moderate eruption at Campi Flegrei, smaller than the Campanian ignimbrite by orders of magnitude, would produce ash fall across a wide area of southern Italy, disrupt air travel across the Mediterranean, and require the evacuation of one of Europe's most densely populated urban regions under conditions that would test every emergency management system Italy has ever built. That is the context in which last night's magnitude 4.7 earthquake needs to be understood. Italy has a civil protection plan for Campi Flegrei that covers evacuation scenarios for the communities within the highest risk zones. That plan involves the potential evacuation of approximately 500,000 people in the event that eruption indicators reach a critical threshold. Executing an evacuation of that scale from a densely populated urban area through road networks that pass through some of the most congested infrastructure in southern Italy is a logistical challenge that emergency managers have studied and rehearsed for years. The communities living within Campi Flegrei know the history of this ground. They have lived with it for generations. Many of the older residents of Pozzuoli remember the evacuations of the 1980s. They remember what it was like to leave their homes not knowing when or whether they would be able to return. And every time the ground shakes, as it did last night at magnitude 4.7, that memory comes back. Last night's earthquake produced no casualties and no major damage. Emergency services responded to reports of stuck elevators and falling plaster. The electricity supply was restored after the pylon collapse. By this morning, the immediate emergency had passed. But the ground at Campi Flegrei is still rising. The seismic activity continues. And the system that sits beneath 500,000 people in the western suburbs of Naples remains in a state of unrest that scientists have not seen at this level in 40 years. Subscribe and hit the bell. Because the situation at Campi Flegrei is one that could develop at any moment, and when it does, you will want to know immediately.